Hey guys, this is Dr. J. So today we're going to learn a little bit about friction, and we're going to learn a little bit about force diagrams, okay? So let's get rocking and rolling. So let me blow this up. All right, and then I'll get us started here. Okay, so friction opposes the sliding motion of two surfaces that are in contact with each other. Okay, so let's talk about some examples of friction at work. Okay, so here are two examples. All right, so your water bottle, when you set it on your desk or when you set it on the floor, it doesn't slide around your desk or it doesn't slide around the floor on its own because friction holds the bottle in place. Okay, similarly, you don't slip and slide around if you're wearing sneakers because your sneakers have rubber soles, okay, to prevent whoever wears sneakers from slipping around while they're moving. Okay, so as always, right, when we're learning about something, we need to understand why learning about that thing or that topic is important, right? So, big question, what if we didn't understand friction, right? Like, what if, and I'm just circling this thing with my mouse so it looked goofy. What if we didn't understand friction, right? Well, let's take a look. Okay, let's take a look at example number one. So these guys think there's not too much friction on the stairs, right? They want to slide down with their mattress. That doesn't work too well. I wouldn't want to be one of those kids, right? With like, oh, that dad does a pretty good job of like getting around so he doesn't actually injure anybody. Good job, dad. Dad reflexes. Yay. All right, let's check this one out, right? So this one, this guy thinks there's not much oh no. There's no friction here. Oh no. Oh, one more time. That's no way to go. All right, I'm sure he's all right. Okay, and then here, right, if you think you've got enough friction, but you don't have enough friction, uh-oh, you just might find yourself stuck in some hay, right? Oh, that's no good, especially with only the front wheel drive. Oh, that is not it. That is not it. Okay, and then what else is going on? Oh, this one was interesting. So here we go. When there's not enough friction and you start going too fast down the slide, so be careful, right? Be careful what you wish for. Okay, you think it's going to be really fun just sliding down this thing, but you know, then physics take over and physics takes over and suddenly you're you're doing this, right? That's not good for your spine right there. Okay? Not good for your spine. And one last one. All right, so here, right, when you fail to understand just how strong friction is and just how much heat, okay, friction can produce. This isn't rubbing your hands to warm them up when it's cold outside. Oh, this is not good. All the smoke, and where there's smoke, there's fire. Oh no. Oh no. Stops this party in a hurry. Let's watch again. Ooh. Right? Can you imagine spending all that money on that car and then whoo, that is no good. That is no good. That's a nice looking Mercedes too. All right. Okay, so a big question then is how to represent or conceptualize friction. Okay. Oh, and let me change this so you can see me. Okay, there we go. That'll take care of the blurriness if there is any. Okay, so how do you represent or conceptualize friction, right? And this letter is an E, represent. Okay, so what we have to use are these wonderful diagrams called force diagrams. Okay, and that gets a smiley face. All right. And so what are force diagrams? Well, let's go ahead and find out. Okay, so we're going to start an example here. Okay, so our force diagram example will center around a 10 kilogram box that is on the floor. Okay, so we've got this box that has a mass of 10 kilograms and it's on the floor. And this reminds me of you know, a recent episode in my life when my wife and I moved into our first purchased homes. So we saved and saved, and we were finally able to buy ourselves a small little place that we think is really, really cute. And you know, so we had to move in. And so 10 kilograms, right? that's about 22 pounds, okay? And so that's a reasonable box, right? And I had to carry and slide a lot of these around on the floor, okay? So let's diagram what's going on with this box. Okay, so the weight of the box is equal to the mass of the box times gravitational acceleration, right? So weight is a force. Mass we know. G, this is gravitational acceleration. Okay, so as always, force equals mass times acceleration. And in this case, we have 10 kilograms, that's the mass of the box, times gravitational acceleration, which is 9.8 meters per second squared, okay? And that's gonna give us a weight or a gravitational force value of 98 newtons, okay? And so gravity is pulling down on this box with a force of 98 newtons. All right. But the ground or the floor in this case is pushing up with 98 newtons. And we know this. We know that the floor must be pushing up with the same amount of force that gravity is pulling down because the box isn't moving on the floor. Okay, so if the box isn't moving on the floor, then the total force, the overall force on the box is 0. Okay, and the floor is pushing up with just as much force as gravity is pulling down. All right. Now, if I decide that I want to pull this box, right, and I shouldn't draw the arrow that big. If I decide that I want to pull this box with 50 newtons, okay, I'm pulling to the left. Friction can oppose me, and friction might oppose me, okay, by applying 20 newtons of force going the other direction. Okay. Now the box would still be accelerating to the left because 50 newtons minus 20 newtons, well, that's equal to 30 newtons, okay? And so my overall force to the left, all right, I have 30 newtons, and this is called my net force, okay? Or my sum of forces, all right? So this box would be moving to the left. So there's an overall net force acting to this on this box of 30 newtons to the left. And so this box under these circumstances is gonna slide along the floor, okay? So we just drew a force diagram with 4 different forces acting on the box, and we calculated a net force. We're going to need and we're going to have more practice, okay, with force diagrams. But we also have to ask ourselves, okay? We also have to ask ourselves, how are frictional forces calculated? And I'll rewind that just a little bit. Okay, how are frictional forces calculated? That is something that we will talk about next time. Okay, next time.